All right, guys. So as always, if you have any questions, just please feel free to ask away or shout them out because I can't really see you guys as I'm writing on the iPad as well. But Unit 1 is going to mainly determine with functions and equations, typically some linear functions, but not always. And we'll do some actually quadratics and some cubics today. So when we first start off talking about functions and equations, first question we want to look at is, what is a solution? What makes a graph? And so to make the graph of this line, you're actually just looking for the set of numbers that make that a true statement. So it says determine if 213 is a solution. Well, all we do is take the 2, plug it in for x, the 13, plug it in for y, and see if that makes it a true statement. So here we go. 13 equals 10 times 2 minus 7. Okay, and that is true, right? Because 20 minus 7 is 13. So yes, that is a solution, okay, because it made it a true statement. So similarly for the second one, we plug -1 in for x and -3 in for y. So we have -3 equals 10 times -1 minus 7. Well, -3 does not equal -17, so no, that is not a solution. So solutions are simply the values that you plug in for x and y to make it true. And sorry, I'm just letting somebody in here. Okay, if you just joined us, we are working on the Unit 1 notes, which you can find in Schoology. All right, so what does it mean if something is a solution? They make the equation a true statement. And there are a bunch of things that make the equation true. In fact, an infinite amount of sets that make the equation true. When you connect them all, then you get yourself a line or a graph of the function if it's not linear. So for problem 2, if we want to use this equation here, and we're just going to make an XY graph, or chart, I should say, I'm sorry. So we're going to plug in values for x, and we can choose anything we want. We typically want to choose some negatives and some positives. So I'll do -2, -1, 0, 1, and 2. So when I plug -2 in for x, -3 times -2 is 6, plus 6 is 12, meaning -2, 12 is a point on the graph. When we plug -1 in for x, -3 times -1 is 3, plus 6, which is 9. So -1, 9, that's a point on the graph. Okay, so I'm just plugging in the values for x to get a value for y, and then those are going to make coordinates. So if you plug in 0, if you put 0 into the equation, you get an output of 6. If you put 1 into the equation, -3 times 1 is -3, plus 6 is 3, we get an output of 3. Plug 2 into the equation, we get an output of 0. And so now we have a pretty good set of data there that we could plot on the graph below. So -212 is going to be up here. -19, 0, 6, and 1, 3, and 2, 0. If I'm going too fast, please just let me know. So I want to connect those. And notice if you connect them, of course, we get a straight line. And now those are only some of the solutions. There's actually an infinite amount. You know, this point here, and this point here, and this point here, and this point here, and every little point in between there. We just took some nice integer values. But of course, all those values in between also make that a true statement. So we're going to do something similar with the next one. So I'll stick with the same -2, -1, 0, 1, and 2. And I'm going to plug those numbers in. But now we're using this equation, of course. And so if I plug -2 in for x, remember -2 squared is -2 times -2, which is +4, times 4 is 16, and -6 is 10. So -210 is a point on the graph. All right, -1 squared is 1, times 4, and subtract the 6, we get -2 as our output there.
Can you slow down a little bit?
Yeah. And so plugging in a 0, 0 is always a nice number to try because anything times 0 is 0, meaning this part just becomes 0. And we get an output of -6. So 0, -6 is a point on the graph. Now, if I plug +1 in here, well, +1 squared is 1 times 4 is 4. So I get an output of -2. And if I plug in +2, I'm going to get an output of 10. All right, so again, we have a decent amount of values here. This one's going to look different than the previous one. The previous one was linear, of course. So this one, -210, that's going to be up here. And -1, -2. 0, -6. So those values are going down. But then the graph seems to go back up because 1, -2 is there. And 210 is up here. And when we connect those guys, we get a parabola or a U shape. Now you may have recognized that because it's a second degree polynomial. Remember we talked about degrees? So second degree polynomials make quadratics. They make parabolas. Just like first degrees make lines. So those are linear and those are quadratic. The next one is a third degree or a cubic. So let's plug in the same numbers, -2, -1, 0, 1, and 2. All right, now when I plug -2 in for x, we do the cubed first, of course. We do -2 times -2 times -2. So negative times negative times negative is going to be a -8. And then times this other one will make that +8 minus 1, which is 7. So -2, 7 is that point, is a point on the graph, I should say. When we take -1 and cube it, we get -1. So the opposite of that would be +1. And 1 minus 1 is 0. So negative 1, 0 is our next point. Now remember, plugging in 0, I love 0 because it's typically really easy to do. You plug in a 0 and we just get an output of negative 1. Now if I plug in 1 cubed is 1, and the opposite would be negative 1 minus 1 would be negative 2. And for my next one, we're going to get negative 9 as our output. So 2, negative 9 is our last coordinate that we're going to find. So I think we should have enough to get a pretty good idea of what this graph looks like. So let me take a look here. Negative 2, 7, that's going to be up here. And negative 1, 0. And 0, negative 1. And 1, negative 2. And 2, negative 9. So that might look weird, but the more we get used to these, you'll realize that those cubic functions have this basic shape to them. All right, any questions yet?
I don't know if this is a dumb question, but like for the x's, can we just put like random numbers in? Like, does it have to be negative 2, negative 1, 0, 1, or 2?
That is a great question, not a dumb one at all. No, you don't have to put those numbers in. The reason I chose those numbers, it's a good idea to try a negative number because, you know, when you square it, sometimes it turns positive. So it's a good idea to try a negative number. It's a good idea to try 0, and then a good idea to try some positive numbers. So that's just how I ended up with those. Okay, but you can do anything that you want. All right, let's keep rolling here. All right, so now we're gonna kind of focus in on just the linear ones. So focus in on lines. Well, lines have, of course, a slope. So you might remember from the glory days of Algebra 1.
Oh
To find
God,
your...
I blocked this out of my memory.
Yeah, I know. It's coming back with a vengeance now. Don't worry, it's gonna be all right. We have subtract the y's on top, subtract the x's on the bottom. So slope is, you might have heard a million different kinds of expressions. Y2 minus y1 over x2 minus x1, or change in y over change in x, or rise over run, or rate of change. All of those things really mean the same thing. Okay, they're just how much the graph is changing from one point to the next. And so when you look at that, you're looking at the change in how far vertically, or the rise, and then how far horizontally, or the run. So an equation is to subtract the y's on top and the x's on the bottom. So for example, if we wanted to find the slope here, now the order doesn't matter if the y values are the 0 and the 1. It doesn't matter if I do 0 minus 1 or 1 minus 0, as long as I do the same order on the top and the bottom. So I did 0 minus 1 on top, so I'm going to do negative 2 minus 3 on the bottom. And I would get the same answer if I went the other way with it. If I went, you know, if I went 1 minus 0 and then 3 minus negative 2, we would get the same answer, because in this case, we're going to get negative 1 over negative 5. And a negative divided by negative, of course, is a positive. So that is a slope of 1 over 5, or 1/5. Now for part B, I have 2 minus 2 on top and negative 1 minus 2 on the bottom. Well, 2 minus 2 is 0. And 0 divided, as long as the bottom is not 0, 0 divided by anything is going to be 0. So I know that that slope will be 0, which actually is going to be a horizontal line. The slope of 0 would be horizontal. So for the next one, I'll do -1 minus 4 on top and 1 minus 0 on the bottom. So we have -5 over 1, or a slope of -5. I probably should write that a little bit neater, but a slope of -5. You don't have to write the over 1, of course. And then last but not least, if we had 4 minus 1 on top and 3 minus 3 on the bottom, now I get 3 on top, but I'm really concerned about that 0 in the denominator. If you get a 0 in the denominator, that means that the slope is undefined, meaning that graph would be a vertical line. Okay, so what would each of these slopes look like? Well, this slope is going to go up, and this slope is going to be horizontal, and this one's going to go down, and this one's going to be vertical. And in fact, later on, we'll talk about the fact that those two are actually perpendicular, and we'll get to that in a few minutes. But before I move on, do you guys have any questions on the slope? All right, we're rolling then. So we want to, when we're writing the equation of lines, there's two forms that we use quite a bit: point slope form and slope intercept form. And point slope form is probably the easiest, but slope intercept form is perhaps the most useful. So it's good to be able to use both of them. So for the first one, we want to write the equation of a line that has a slope of 3 and a point through 1, -2, but we want to do it in point slope form. Well, point slope form, that means that m is our slope, so that 3 is going to go right there. And the 1 is our x value, and the -2 is our y value. And the other x and y stay as variables in the equation. So that is going to be y plus 2 equals our slope, which is 3, times x minus 1. That would be that equation in line with the slope of 3 and through that point. All right, now the next one's going to be a little more work. We're going to write this in slope intercept form. Well, if we're going to do slope intercept form, we first better know the slope. So to find the slope, I'll subtract the y's on top. So 0 minus 1 on top, and the x is on the bottom. -2 minus 3 on the bottom. And so cleaning that up, we have a slope of 1/5. Now, I can write that in slope intercept form. I can write it in point slope form very easily because I have either point and I could just choose one. So if I wanted to use this and write it in point slope form, I would get y minus 0, which I wouldn't even have to write the minus 0, equals our slope, which is 1/5, times x plus 2, because it's minus -2. So that would be in point slope form. But the question asked me to write it in slope intercept form. So all I need to do is solve this for y, or get y by itself. Well, again, I don't need to write the minus 0, and I can distribute the 1/5, so I get 1/5 x plus 1/5 times 2 is 2/5. So in slope intercept form, it's y equals 1/5 x plus 2/5. All right, so to write the equation of the line, it asks in slope-intercept form again. Well, we need a slope and we need an intercept, but in this case, they give us a graph. So there are many different ways we could do this. I could use the coordinates here, like this is at 0, 3, and this is at 2, 0, and do what we just did in the last problem. However, to find the slope, I also can do the rise over the run. So to find the slope, the rise, this goes down 3, and the run, this goes over 2. And so we have a slope of -3/2. And the y-intercept, actually, where it hits the y-axis, that is right there. Our y-intercept is 3. So our equation is y equals mx, or -3/2 x, plus our y-intercept, which is 3. So there are other ways we could do it, but I think that is the easiest and most efficient way to do that problem. So we'll do part B to determine that line. I'm going to do the same thing. The slope is the rise. Now notice these are each 2 units, so that was 6. And the run is 1, 2, 3. So I actually went down 6 and back 3. So our slope was -6 over -3, which is +2, which makes a lot of sense because my slope is going, my line is going upward. So we should get a positive slope. We have a y-intercept of 6. So I get y equals 2x plus 6. All right, any questions yet? We're rolling. We got one more thing. So if we have more than one line on a graph, sometimes they oftentimes cross each other or intersect, but sometimes they don't. Sometimes if they don't intersect, that means they are parallel lines. So in parallel lines, that means you have the same slope. Okay, lines that are parallel have the same slope, as opposed to lines that are perpendicular. Now, perpendicular, remember, means they intersect to make a 90-degree angle. That means the slope is the opposite reciprocal. So an opposite reciprocal means, opposite means if it's positive, you make it negative, or vice versa. And reciprocal means you flip it over. So for example, we're trying to write the equation of a line that's perpendicular to this guy. Well, I know that the slope of that is 2/3. So the slope of something perpendicular to that is -3/2. Okay, opposite, and then flip it over. We want it to be perpendicular to that and go through the point -3, 0. So in writing it in point slope form, I have my y minus my y value equals my slope, which is -3/2, times x minus -3, which is x plus 3. And you wouldn't need to write the -0. That's kind of silly to write in math. I just put it there to help you with the notes so you realize that's where that came from.
If we leave it, will it be marked off?
No, it will be, either way it would be fine.
Okay.
All right, so next we want to write the equation of a line that's parallel to this guy. Well, if it's parallel, that means, again, they have the same slope. So I need to figure out the slope of this, but it's not in a very nice form. It's actually in standard form. So I need to solve it for y. So I'm going to move that -2x over and write that as 3y equals 2x minus 12. Notice I put the x part first so that it ends up in slope-intercept form. And divide everything by 3. So this equation is really y equals 2/3 x minus 4, which is much easier for me to see that the slope is 2/3. So the slope of a line parallel to that will also be 2/3. Here's my point I'm going to use. So we have y minus -3, which is y plus 3, equals our slope of 2/3 times x minus 1. And if we wanted to convert that into slope-intercept form, we would just distribute the 2/3 and then move the 3 over, and it would be in slope-intercept form. All right, guys, any questions?